The overall conviction among most specialists is that the hypothesis of how things came to be stays the major explanation for the early seasons of the universe. This speculation joins the improvement of stars, planets, and, in this way, forward, life on those planets, counting ourselves. Despite its odd name, the enormous detonation, it offers an enlightening evaluation concerning what might have happened at first. The universe was thick in a short space, more thick than a pinhead, with particles thickly pressed. From this moment, a beast impact of matter and energy happened, known as the enormous detonation. This event, happening billions of years ago, set up the spreading out of colossal history. In any event, insensible data, it has set off making mannerisms with the suppositions of this speculation. Right when NASA sent off the James Webb Space Telescope, the largest and most exceptional space science observatory ever, specialists estimated that its knowledge would affirm the speculation of the universe's beginning stage. Unfortunately, after just a single year in space, the telescope staggered specialists with its capacity to peer so deeply into the universe's past. The James Webb Telescope's stunning abilities have uncovered countless universes, going as far back to a period so old that it challenges how we could decipher the universe's beginnings. This exposure has begun a serious assessment concerning what existed before the enormous bang. One pivotal moment in this mission happened when cosmologist Rohan Naidu, working with information from the telescope, startlingly tracked down a framework from just a short time frame after the Big Bang, making it the most far-off universe at any point seen. Naidu's revelation sent shockwaves through laid-out specialists, highlighting the astonishing abilities of the James Webb Telescope. Its tremendous potential to significantly impact our viewpoint on the universe has scarcely begun, promising to uncover astonishing bits of knowledge into the earliest times of the universe's presence. This period, barely engaged on beforehand, holds the way to getting a handle on the advancement of the first stars and systems. The telescope's disclosures have conflicted with head theories, revealing frameworks with ascribes defeating past presumptions. This uncommon surge of early universes has started a tempest of logical request, testing specialists to adjust these disclosures to existing speculations. As investigators uncover these openings, they face key inquiries regarding the very nature of the universe and the powers that shaped its development. Beyond the James Webb Telescope's benefits, which are clear, it is seen as 1.5 million kilometers away from Earth, protected from endless obstruction, and cooled to move toward absolute zero by its tennis court-sized sun shield. The telescope integrates an immense piece of reflect and amazingly delicate instruments, expected to uncover subtleties of the early universe, previously confidential. This period, known as the enormous daybreak, happened around 200 to 300 million years after the enormous detonation, marking the point at which the first stars and systems began to form. The cycle by which this unfurled remains a subject of perfect inquiry, with speculations ranging from the impacts of dark matter and dark energy to the connections between star-forming gas and dust. The telescope's viewpoint on universes from the grandiose daybreak presents a clever opportunity for cosmologists to test how they may interpret these intricate parts. By concentrating on these antiquated frameworks, experts can either affirm the legitimacy of their ongoing models or reveal holes in understanding that could lead to major new revelations. The telescope was supposed to take note of a couple of weak and small systems in its pilot studies. However, the truth has far surpassed these expectations. The telescope's early pictures of the far-off universe uncovered a wealth of cosmic systems with ages, sizes, and brilliance levels that challenged all expectations. This stunning flood of early cosmic systems has started a race among space scientists to establish new standard records for the earliest known gigantic frameworks, with new relations arising continually, leaving common experts in wonder. Following the James Webb Telescope's openings, educated authorities and spectators have rushed to concentrate on the presence of these amazingly advanced early universes. Some speculated that blunders in the telescope's understanding of colossal perceptions could be liable for these disturbing disclosures. That said, the consensus remains that these discoveries represent a change in perspective by the way we could decipher the early universe and offer invigorating looks into the potential for gigantic advancement. The new revelations from the James Webb Space Telescope about worlds have raised critical questions regarding the nature of the universe and tested the assumptions of standard cosmological models, while some experts are inspecting whether these bits of knowledge can be obliged with existing speculations. Others recommend that they might be the main signs that the universe is undeniably more confounded and confusing than previously envisioned. The vital inquiry in play is our basic comprehension of how the universe we know rose up out of early-stage tumult. The early discoveries of the JWST could reshape our core thoughts of infinite history, uncovering bits of insight not simply on far-off universes and antiquated structures, but also on the actual nature of our own Milky Way. As Mark McFan, senior researcher for science and investigation at the European Space Agency, puts it, "You fabricate these machines not to affirm speculations, but to break them. You simply have no clue how it will break." The beginnings of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was entrusted with envisioning what could come after Hubble. Notwithstanding initial doubts, Weir and a small group began laying the foundation for what would ultimately become the James Webb Space Telescope. Unlike Hubble, which essentially captures visible light, the JWST was designed to observe in the infrared range, permitting it to peer much further into the universe. This capacity is critical for studying distant galaxies, whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its enormous, cold, star-like mirror, the JWST became the chief instrument for revealing the secrets of the inestimable first light. The need for the JWST was highlighted in 1995 when the Hubble Deep Field Observation revealed countless galaxies in what was once thought to be a blank patch of sky. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of analyzing far deeper into vast history. After some serious time development and an expense of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most critical year of scientific observations. Early drives like the Early Release Science Program and the General Observing Program were specifically designed to search for early galaxies. While initial assumptions were modest, the results far outperformed them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These staggering discoveries highlight the significance of pushing the boundaries of scientific inquiry and showcase the exceptional capabilities of cutting-edge technologies like the James Webb Space Telescope. As researchers continue to investigate JWST data, they may uncover further insights that test and expand our understanding of the universe. When the first data started coming in from the JWST, cosmologists eagerly anticipated the results. Many had been preparing their data analysis pipelines for this moment for years. Instead of following the traditional peer review process, which typically takes months, scientists decided to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed a new kind of peer review to happen through online platforms like Twitter, where established experts could immediately discuss discoveries. Rohan Nada described this process as science by press release, and the resulting storm of conversation was both intense and remarkable. However, there were concerns about the potential drawbacks of this rapid spread of results. Klaus Pontypool, a JWST project researcher at STSCI, cautioned that while the fast sharing of results facilitated quick dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most scientists is that the theory of how things came to be remains the primary explanation for the early times of the universe. This theory encompasses the formation of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang Theory offers a compelling explanation for what might have happened at the universe's beginnings. The universe was densely packed into a space smaller than a pinhead, filled with tightly packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set the unfolding of cosmic history in motion. However, changes in scientific data have led to anomalies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, scientists estimated that its observations would support the theory of the universe's origin. Unfortunately, after only 1 year in space, the telescope astonished experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's abilities have revealed galaxies dating back to such ancient times that they challenge how we interpret the universe's origins. This discovery has sparked a serious reassessment of what might have existed before the Big Bang.